Okay, ladies and gentlemen, let's talk about some nonlinear inequalities. Now, of course, nonlinear means non-straight line. Inequalities means we're going to be dealing with greater than, less than, greater than or equal to, or less than or equal to. Now, what we would do is if we had this as a just nonlinear function, we would say f of x equals x squared, well, x plus 4, x minus 2. Now, we could say, well, that's fine. I can multiply them together. That's going to give me x squared plus 2x minus 8. And we could graph that, okay? And so if we're going to graph this, it's going to look like the following. It's going to be a solution at 1, 2, 3, 4. It's going to cross there. 1, 2. It's going to cross there because you set each piece equal to 0. Now, we know it's a parabola, and we know it opens up, so somehow it does this. Somehow it does this. Now, what we're doing is we're actually asking, where is the graph itself greater than 0? That's really what we're asking. So where's the graph itself greater than 0? Well, the easy answer is, well, here and here. Okay, well, where is that? Well, that's going to be from 2 to infinity, because it's going this way, infinity, okay, remember. And so that's a parenthesis. What would go here? Well, it's greater than or equal to 0, so bracket. Now over here, I have negative 4, and again equal to, so bracket, and that's negative infinity. So from negative infinity to negative 4, it's greater than 0, and from 2 to positive infinity, it's greater than 0. Okay, so that is where x plus 4, x minus 2 is greater than or equal to 0. Now, if I wanted where it was less than 0, by the way, it would simply be from here to here. And it would be this area. So greater than 0 above the x-axis, because that's positive 1, positive 2, positive 3, positive 4, positive 5. Down here is negative 1, negative 2, negative 3. So greater than 0, less than 0. So graphically, it's very easy to see. Now, another way we can look at this is let's look at it in terms of a number line, because all we really care about are the x's. Well, I know I'm going to have some key things happening at negative 4, and I'm going to have some key things happening at positive 2. So the question is it positive or negative in this area, positive or negative in this area, positive or negative area in this area? Well, the easiest thing is let's try something. Well, 0 happens to be in here, so let's try 0. If I say 0 plus 4, parentheses, 0 minus 2, that's going to be 4 times negative 2, which is negative. So in this area, it is negative. If I come over here and say, let's try negative 5. Well, negative 5 plus 4, negative 5 minus 2. That's going to be a negative and a negative. So two negatives together make a positive. In this area over here, let's try 3. 3 plus 4 is 7. 3 minus 2 is 1. So it's going to be, again, positive, and positive is a positive. So you'll notice positive in this area of the number line, negative in this area of the number line, positive in this area of the number line by substituting values in. In this case, we graphed it because it was fairly easy to graph. And we say, well, there it is, and there it is. And it matches. It's these two areas are the same as these two areas. So that is solving nonlinear inequalities. It's either by graphing or the number line numerical method. Either one of those is just fine. Okay, now if we have something that's a little different, let's say we have something that's rational algebraic, we still go through our standard process. Our zeros are at negative 2 and positive 3/2. So 1 there and 1 there, so it's going to cross. We also have asymptotes, vertical asymptotes at, let's see here, 3, 1, 2, 3, and negative 1. And then we have a horizontal asymptote, because if I FOIL this all out, so we have verticals at -1 and +3, horizontals, I have the same power on top as on bottom, so my horizontal asymptote is going to happen at 2 over 1, which is 2. So we have this right here. And so at this point, we can figure out that our graph is going to look as follows. And given this information, we need to figure out where is this graph less than or equal to 6. Less than or equal to 6. So the easiest way to find that out is to figure out 1, 2, 3, 4, 5, 6. And so which part of this graph is below that and which part of this graph is above that? Well, we have an above part over here and above part over here. Everything else is going to be below. So we have this is below, and this is below. Now, again, your best way to figure this out would be to solve where is this top less than 6? Where is that top less than 6? But from the graph, usually using rational algebraic, graphing is going to be your best bet, and then figure out where do these pieces cross. So, given that, we're going to have a couple homework problems.